Hello, this is Michael Ratcliffe, and today I'm going to be showing you how to make a Arduino based EC meter for £2. What you'll need a waterproof temperature probe. Everyone should have one of these. If you don't have one, you should order 10. An American style 2-prong plug as a EC sensor. Because these are sold all around the world as a good standard, the pins will always be the same distance apart. They'll always be the same sort of stainless steel material, so they're pretty standard. So when I calibrate this, you should be able to make the exact same one anywhere in the world, and the calibration will stand roughly. You can calibrate your own one if you want, like I'm going to do in the video now, but if you just want something that'll plug and play and be about right, you won't even need to calibrate it. Follow the wiring diagram on how to wire it up. I recommend getting an extension lead with the American plug on one end and this on the other, and buying the male or female, I can't remember which one it is, counterpart to this figure 8, so that when you want to change the EC probe, you don't have to resolder onto a header. You just unplug this and plug your new one in to decrease downtime. Now, I've got one in the post, but for now, because this was just proof of concept, we're using this. Yeah. Now, usually you can't measure EC using DC probes because you polarise the water as soon as you polarise the water, and by that we mean you move the ions in the water, so you can't take a DC measurement. Let's just plot what happens if you try to take a DC measurement of water EC. This is your EC measurement, your resistance of the water. I can't remember whether it's positive or negative relationship, but this quickly happens when you try and take a reading, so this is time. So if you just try to take a DC reading and left it turned on, your EC reading would be wrong, because it would tell you there's an EC of, I don't know, 1, when in fact it's 3. So we get around this by connecting the EC meter to the digital pins of the Arduino, turning power on just for this short period here. So we turn the power on, take a reading quick, and turn it off, so this bit doesn't happen anymore. The wiring diagram will be on the screen now, and just to show that it works, right in front of me here I have got a range of water samples. We've got my tap water, which using this meter here is 0.25 EC measurement, a 1 EC measurement, a 1.38, which is quite a common strength for calibrating EC meters, which we'll be doing now. You've got your 2.01 and your 3, so this is the range of measurements you're going to see in your aquaponics pond or hydroponics. You're never really going to go above 3. You tap, this is the range that you're measuring. So let's start by calibrating it. What you do is you go to your Arduino, you go to your computer. So what you do is you go to your computer, you open your calibration one. Read the code, it's just generally good practice to know what it's doing. And if you've wired it up like the wiring diagram I showed you a second ago, all the pins will be right. The only thing we're changing is this calibration EC, which is the EC of the fluid we're going to calibrate with. So we said it's 1.38. Click upload. Select the right pin. Open the serial monitor. Right, so now we're going to plug it into the temperature probe into the water with the EC probe. Stir it up slightly so we got a good mixture. Now you don't want this probe touching the glass because it'll give the boundary layer will give you bad readings. You need to hold it in just floating, like you would do in your main tank. It takes about 60 seconds to get the reading. The first reading's going to be rubbish because we didn't put the prongs in. Let's just bend that so it stays in without touching the side. And what this will do is tell us the calibration. It'll tell us a K value which we use in the main code. So about now it should have given me my K value. The first one was wrong because we hadn't had the probe in the solution. Right, so we've got our first stable reading. If you look, the first 4 had errors because the temperature probe had not settled yet. So our K value is 2.83. So what we do with that is we go back to the computer, open the main test conductivity test, just check it compiles. Again, read through the code so you know what it's doing. But the main one that we're converting here is, we come down here to the cell constant, and our cell constant is 2.83. Compile the code, upload the code, and now it's uploaded, so it should be running. Just while I'm here, I'll tell you 1 or 2 things about the code. Like the polarization we were talking about earlier, you can't measure the EC more than once every 5 seconds. So if you go down to the main loop here, don't call this get EC more than once every 5 seconds or you'll get bad readings. Anything over 5 seconds and there's no problem. Open the serial monitor. And if you look here, the first reading's always garbage. The second one, it's given us an EC reading of 1.38 like you would expect. So take your probe. I'm just going to show you that it works for all the others. We'll start at the tap water, which is over here. So we've just placed it into the tap water, and our reading now should be 0.25. It's 0.23, close enough. Into the 1.036, and our reading is 1.09. We've already done the 1.38, so we'll put it into the 2.01. And we're getting 2.06. And into the 3.0 flow. Again, stir it up so you know you're getting a coherent reading. Who's touching the glass? It's giving us a rating of 3.07. Right, so here are the readings that we got from the Arduino. The ones in red are the ones from the EC meter. The ones in the Arduino, so 0.25, 0.23, close. Close. Bob on, because this is the one that we calibrated against, so that's what you'd expect. 2.01, 2.06, very close, 3.04, 3.07, very close. So they all pass the test and it works. As you've just seen, the code works. For the temperature compensation, you're just going to have to believe me, it works because I have tested it. Now, I'm going to stress again, you can't call the VDC function more than once every 5 seconds because you'll degrade the probe and get bad readings. Calling it once every 5 seconds, I've left it running for 24 hours without seeing any change in the readings. So it seems that once every 5 seconds is okay. Now, as for the probe, with this, it's an American style 2-prong plug, just generic. The good thing about this is anyone in the world can buy one of these plugs, and the calibration factor that we worked out to be like 2.8 will be the same for all of them. Now, because I'm not in America, I didn't have a lot of these plugs, so I had to cut one off and solder it onto a header. But what I recommend doing, now because I'm in England, I didn't have a lot of these plugs. They're very cheap to buy on eBay. I've just ordered another one for £1 with one of these ends. So instead of because these do wear out and I'll need to clean them and they're that cheap, I'm just going to swap them and throw them away. So to save having to solder onto a header each time, I'm going to solder this header onto the counterpart of this. So you just buy a plug extension, plug it into your case and unplug it and replace it whenever it does need replacing. So I recommend using this end and the female part on the Arduino. Now, where I live, I've not got a plug I can plug this into, so that's not a problem for me. But if you're in America, you're going to have to make sure that nobody plugs this probe into the mains, because it'll put mains power to your analog pins and fry your Arduino straight away. But for me, that's not a problem, like I was saying. Now, what other measurements could you do with this? We took the resistance of the digital pins into account. So this could be used to measure, you can't measure an EC over 3 with it because your digital pins just can't supply that much current. But you could measure by changing the resistor here. You could use it to measure the quality of drinking water as well by increasing the resistance. Now, these plugs aren't completely sealed. Inside seeps a little bit of water and you get a little bit of resistance inside. It's in the megaohms range, so it won't affect us measuring these fluids. Very small effect, less than 0.1%. If you try to measure ultra pure water, it will become a fact and you'll have to take it into account in your calculations. So there you have it, a $2 EC meter for your aquaponics, drinking water, hydroponics. Take a look at the codes, read them through, because there are serious restrictions on what you can do with them. But what do you expect for £2? Anyway, keep up watching the tutorials because there'll be more on the way. The next tutorial I'll be talking about how we can use the same Arduino on this to dose a hydroponics system. So keep watching. Beep.